All right, let's start this class, okay? Yeah, I know you guys will have the rate of change test, okay? Yeah, because this is no longer a pre-AP or AAC. This is a AP class. So you have to compare to the previous AAC, this add a lot of new contents. Rate of change is this new one because it involves a derivative concept, which is hard to understand. That's why you may feel this part challenging for you, okay? But as long as you do with me together very carefully and work hard, this question should never ever bother you anymore. Let's take a look at this. I upload this. If you didn't open the new folder, I mean this 02 folder, please open it. I upload the two new worksheets, which will be very helpful for your tomorrow's quiz. This one, we go do backwards, okay? We do this day 5, and we do from the last question to the first question. So the first question is 38. This asks you, okay, look at this graph. Look at this graph. Before we see the question, let's observe this thing first. If I get rid of this, let me call student, okay? Lorena. Is this increasing or decreasing?
Increasing.
Increasing. So all the way from here to there and to here, they have increasing all the way from negative infinity to positive 2. So all this is increasing. But over here, this is called decreasing. Increasing, decreasing, depending on from the left to the right, you are climbing up or you are going down. A new concept is called concavity. Students feel confused about concavity. Here is the best way to know the concavity. For this piece, you can suppose this is a cup. Okay, Lorena, look at this. Unmute yourself. This has a cup. And this cup, you can see this cup you are opening up. Yeah, you hold this cup, and this cup is face up. So this is called concave up. For this part, this is a part of the cup. The cup should be looks like this. You want to hold this cup, you have to hold this cup face down. So this part is called concave down. Again, come to here. This is a half a cup. If you want to hold this cup, it has to be this direction. So this is concave up. And then come back to here. This guy, you hold this cup face up. So this is concave up. So concave up, increasing. Concave down, increasing. Concave up, increasing. Concave down. Sorry, this is concave up, decreasing, okay? Increasing is going up, decreasing is going down. First derivative, all you see the rate of change, the first order, rate of change. This rate of change is positive. This rate of change is also positive. This rate of change is negative. But this concave up, the part, the rate of change, if it's concave up, the rate of change is increasing. This part is concave down, the rate of change is decreasing. I know this is something very confused, okay? So let's look at the list of the question. Let me call students, okay? Hopefully, after we work on this, everybody should feel comfortable with this for tomorrow's quiz, okay? Krisha, from where to where it is increasing? Let's go all the way to negative.
Okay, yeah. From negative infinity to 2.
Yes. Decreasing?
2 to infinity.
Very good. The concave up. Do you see where is concave up?
Yeah, yeah. So from negative infinity, or I don't know. Yeah, I guess so. Negative infinity to negative 2, 0 to 2, and
Yes.
yeah.
Yes, very good. And concave down is here. Okay. Yeah,
Yeah.
you can check this cup you hold face up, face down. It's concave down. Next, the extrema. You might say, what's this name? Okay. Yeah. In Algebra 2, we learned the polynomial. Last class, we also draw the polynomial. If you draw a curve from negative infinity to positive infinity, okay, it only show part of this. And then if you want to find out the extrema, you will check this guy for the whole thing showing here. Because this is suppose going down, follow this trend. This is going this way, following this trend. So you can have a maximum point right here. So that's called a global maximum. Okay, that's called a extrema. All these names, terms you see here. Next year, this is in calculus AB and calculus BC. Okay, so basically they add this to prepare students for next year calculus. So the extrema is that point. That's the extrema. And then what else? Point of inflection. This is something new. Everybody has to pay attention. The inflection point. You cannot just randomly pick any point as inflection point. The inflection point is always the point where the concavity change. I say this one more time. The place the concavity change is right here. The place the concavity change is inflection point. This guy here, up. This guy here, down. So that point is called point of inflection. Okay. Now, next year when we learn calculus, we will calculate first derivative, positive. Let me write down a summary here. Okay. Let me write down a summary. First derivative. Rate of change is the first derivative. If first derivative is positive, it is called fx is increasing. Copy down these notes. This is important for now and also for next year. First derivative is negative, fx is going down, decreasing. First derivative only tell you you are going up or going down. Does not tell you if you are concave up or concave down. Concavity, rate of rate of change is called second derivative. If second derivative is positive, you say your fx concave up. If second derivative negative, you say your fx concave down. So there's plus, there's minus. This plus, second derivative is positive, so concave up. This guy here, second derivative is negative, so concave down. You can use a simple case like this. Look at this. This is a parabola. Yeah, so x squared going up. X squared first derivative is 2x. 2x derivative is 2. 2 is positive. So this part is concave up. And this guy is negative x squared. Negative x squared first derivative is negative 2x. And then negative 2x derivative again is negative 2. That's why this is concave down. Remember, I think almost all of you, okay, yeah, most of you have learned Algebra 2 AAC with me. In Algebra 2 AAC, when we talk about the finite difference, I mentioned this thing. It's called the power rule before. If you still remember that thing, this will be easy for you to understand. Okay? Now, if this part makes you feel overwhelmed, don't worry, okay? We have a lot of practice to do this. Now, point of inflection is you switch between concave up to concave down, or from concave down to concave up. So you have here concave down. You have here concave up. So this is another inflection point. You have two. Some people say this is also inflection point. You have to check. That is up. This is concave up. This is concave down. No, this is concave up. So that is not an inflection point. Inflection point is not from increasing to decreasing. Not at all. Not at all. Inflection point is your concavity change. You hold the cup up, you still hold the cup up. You don't have the inflection point here, okay? So the answer is this 2 points only, not this, not this. Next one. This is an easy one. When people get confused, nervous about previous question, and for the easy question, you thought it's hard. No, this is just do what? At 2, this is 3. At 3, this is 1. So y minus y over x minus x. That's easy one. Basically, they ask you if you connect here, what's the slope? This slope is negative 2 over 1. So that's easy. Next. The rate of change are increasing. Hold on. That thing, some people think the rate of change, so you are looking for the increasing. No, the rate of change are increasing. This is for the second derivative. So over here, from 2 to infinity, this is concave up. This is concave up. So the rate of change are increasing. Is 36 confusing? I know a lot of people want to choose false here because from 2 to infinity, it's going down. No, they ask you the rate of change. The rate of change are increasing. The rate of change are increasing means your slope here is negative infinity, yeah? Your slope, you are looking for the instantaneous slope or the tangent line slope. So you have a line here. For this line here, tangent line is this. This tangent line has a vertical line. So you see this slope here is negative infinity. And then you're going down, it becomes mild. And then come down, your slope becomes like 0. So that means you're from a negative 100 something towards 0. So your rate of change is increasing. So this is true. If you see this in your school's test, that's a question many students lose the points, okay? Next one, 37. The rate of change are positive from 2 to infinity. The rate of change is asking this part slope. This part slope is this guy is going down. So the slope or rate of change is negative. So this is false. Okay? This is false. Next one, last question, 38. What interval is the rate of change the greatest? The rate of change at what interval? So you can see here, this is -2 to 0. That's why the last step here, okay. The last step here is basically asking you this thing. From -4 to -2, you draw this line. And you calculate this pink line slope. And then you calculate this pink line slope. And then that one and that one. They ask you which slope is the highest. This has the highest slope. That's why you choose B. I'm going to highlight the question I think students might have trouble with, okay? You might, I think most people have trouble with 37, 36, inflection point, extrema, concave down, concave up. Other parts are easy. Before we move to next question, is there any question? No. After I teach you these several questions, I know before today's class, I know some kids are very nervous, okay, very has anxiety about tomorrow's quiz. After I teach this, if you feel better, please knock your head. After I teach this question, you feel better, knock your head. If you keep going, okay, yeah. This is just the first one to let you, because this question summarizes everything you have learned so far. First, rate of change is increasing or decreasing. Rate of change. Rate of change is a second derivative. It's called concavity. Positive concave up, negative concave down. They can also say, hold on, okay? This is another way to say concave up. This is another way to say concave down. Hold on, okay? Increasing, if you say rate of change are increasing, this is called concave up. If you say rate of change are decreasing, this is called concave down, okay? Don't confuse this with this. This positive is going up. This is concave up. Next. If you don't understand this part here well, next year your calculus, no matter you take APBC, you're still struggling for here, okay? So let's get this clear from now on, okay? And AP exam, I guarantee you will see this question. So this is about graphing. I first graph this with your guys. And I show you a way to draw this one very fast and guarantee you to get perfect result. Over here, Brianna, you can unmute yourself, please. Average rate of change is the slope, which I call this first derivative. Okay, this is called rate of change, which is a slope, which is the rise over the run, which is a first derivative. Positive means your curve is increasing. Negative means your curve is decreasing. Now, this is easy to understand. That guy here. Average rate of change is decreasing. This is the second derivative. Remember this thing we talked about just now. The guy here is that guy. Yes?
Mm-hmm.
Okay. So rate of change is increasing is concave up. Rate of change are decreasing is concave down. I hate saying this because students will say positive going up, increasing. This is decreasing. You want increasing or you want decreasing? No, they are talking about different things. So that's why I don't like the word they say this. I got confused too. I know this decreasing says concave down. So I immediately rewrite this. This say that guy is decreasing, so concave down, decreasing, concave down, increasing, concave up, decreasing, concave down, increasing, concave up. I switch this. I switch this to the way I understand better. And then when I draw it, it has -3, 0, 2, 6. Less than -3, positive, of course, going up. Going up at the same time, concave down. You go this. Some people say, no, I want to draw this. No, no, no. If you draw this, the concavity is 0. This line slope will be a constant. A constant slope will be 0. You cannot draw a straight line. You draw a straight line, this is 0, not decreasing. So you have to draw this, and it's concave down. You have to face the cup down. So go up, but concave down. And then this is negative. So you go down and concave down. And then this is go down, concave up, face up. And then go down and concave down. Last, go up, but concave up. Go ahead. Hold on. Go ahead. Draw your own pictures based on the hint I give you. Increasing, decreasing, everybody can handle. Use my simple way of face up or face down, okay? So you can draw this curve easily. Your cup, this is called increasing face up. This is called increasing face down. This is called increasing face up. This is called increasing facing down. This is called decreasing facing up. This is called decreasing face down. Okay? Draw your own picture and send me, please. When you truly understand, you feel much better, okay? Before you leave today, if you think this thing totally prepare you for tomorrow's quiz and you feel much better, show me a happy smile, okay? Extrema can be global maximum or global minimum. The previous one, you don't have the global minimum is because this go infinity. This go infinity. That's why we don't have a global minimum, because they have this thing here. If they don't have this thing, if you put a dot here and a dot here, you can call this guy extrema minimum also. But that's a good question, Lauren. Very good, Brianna. That's beautiful graph. Brianna, you draw this by good notes or you draw this by hand?
By good notes.
Okay. No, you can draw this by hand. Your drawing skill is advanced. You can draw this curve perfectly. Same thing to Lorena. You both can do this by hand. Everybody, I believe everybody should send me your work so that I can check for you. Krisha, you have to on purpose to show your curve is concave up or concave down. From -3 to 2, it's kind of like a straight line. You have to on purpose show the concavity. Otherwise, your school teacher will take off a lot of points, I know, okay? And the teacher grade very mean, okay? Same thing for you, Sean. No, Leslie. The curve you show here, okay? I want you to, if you are not used to draw lines smoothly, you want to practice this. You say, oh, you have good nose, you can draw perfectly. No, even I draw by hand, I still can draw smoothly, okay? You want to practice your drawing. In your test, if you give something like this, teacher say, this part wrong, grading part all wrong. This thing, the concavity is 0. It's a straight line. A straight line, the second derivative will be 0. So the concavity will be 0 for this part. So that graph will count as wrong. You have to on purpose to show this curve. You have to on purpose to show this curve. You have to on purpose show this curve. Okay? I want you to have this shape of cup. Don't give me a cup like this way or this way, okay? So Leslie, the graphing is not good enough. Yeah, Kelly. Yeah, that's pretty good, Kelly. Kelly, also practice it. Make it a little bit smooth, okay? Kelly, very good. Make it a little bit more smooth. Sophie, make this a small, tiny change. I don't want you to have a small hump here, okay? There's a small, tiny hump here. Sophie, you understand? Yeah. Don't make a small hump here. Make it flat here and go down. Same thing for you, Ryan. Ryan, don't make a small hump here. Go flat, flat, go down. Okay? Ryan, yes? You understand what I say? Don't make a small hump here, okay? Yes, Owen, yeah. Owen, put the X value. You don't put the X value, they also take you a lot of points off. Same thing in the ApFRQ, okay? You don't have those things, you get points off if you see their scoring guide. Oh, Lucas, your graph is pretty good. You're drawing very nicely by hand, okay? That's very good. Oh, I see. Yes, okay, I see. Oh, you did put it. My eyes is bad. I cannot see it. Okay, I'm going to put my glasses on, okay? That's 28. Every people send me, right? Yes. Okay. Next. 26 is easy. Go ahead. Go ahead, try 26, okay? That's, wait a moment. Oh, not really. Hold on over here. This is just the, you know, for this part, you have to be careful. Some people say this change, the y minus y, this is change. So this is not a constant line. What do you think? You have to pay attention. The x is not increasing by the same interval. So you cannot say, oh, that thing is not equal. You have to be careful. Check if this is a linear function first, and then do the slope calculation, then do the point slope format. You can also do the slope by intercept format. Go, 26, 27. Don't overthink, but be careful, okay? Lastly, this part curve is not good. Lastly.
Yeah, I sent you the correct.
You send me a new one, it's still not good enough. The thing you show me is like this. I need to have a concave down from 2 to here. You see what I mean?
Yeah.
Okay, fix it. I'm not mean. I just want to help you to get the good grade at your school, okay? Oh, by the way, we also need to label, okay? So this part is the local maximum. And this is concavity change, concave down to concave up. So this is concavity inflection point. And this is concave up, this is concave down. So this is another inflection point. And this one here, this is concave down to concave up. So this is another inflection point. You have 3 inflection point here. I want to say one more thing about this. This point has a new name. This point is called a cusp. Okay. You have the curve, smooth. This is smooth. This is smooth. This is smooth. But here, it's not smooth. That's called a cusp. So a graph like this is a cusp. A graph like this is a cusp. Okay? Yeah. To let you remember this cusp forever, I give you a small story, okay? I buy a new bookshelf several years ago, and there's the window, the glasses windows on the top part. So I put my books down, and I guess the window opened. I didn't remember, so I stand up, and it poked into my forehead here, and a lot of bleeding. So this is what cusp is doing, okay? In calculus, cusp is a place where you don't have the derivative. This thing is derivable. Everybody here is derivable. Until here, that point is not derivable. You will learn this first chapter in calculus AB. Okay. So mark it. Okay. Extrema, local maximum, inflection, 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 and this is also a cusp. If you want to write down, you can also say this is not derivable. Go ahead, do 26, 27. Don't overthink. If you overthink, if you do this y minus y, you see it's not the constant. But did you pay attention to the x? The x is not increasing by a constant value. Oh, we have smart student already get it. Very good. Yeah. 3 students already get this perfect answer. That's very good. Okay. So Lorena, Kaylee, Sean, Ryan. Yes, you all get it correct. Okay. Yeah, very good. Don't overthink. Sometimes when you do more complex question, you overthink the question. I don't want this thing happen to you in the test. If you see all the other questions so confusing and you get panic and you lost your pace, and then you overthink this, you thought this is something like a quadratic or cubic or maybe polynomial to the power of 5. No, no, no. It's just a simple linear function. Y minus y over x minus x. You don't divide it by that, of course, you don't get the slope correct. 24, 25, you have to pay attention. I give you a hint. This one, they didn't give you a table. They give you on this interval. This is not -2, This is not your xy, okay? Pay attention. This is not your xy. This is an interval. -2, 1, you have a slope. -2, 1, you have a slope of -3. So you should do f of -2 minus f of 1 over -2 minus 1 equals to that slope. And then you have to do the other one equals that slope. And then you solve the system equation to get your A and B. Okay? And then you find your quadratic. Go. 24. I already give you the hint. You should be able to do it. Did I give you guys, this is a good exercise, right? Is this thing too easy for Clemens? Or is this too hard? I mean, or is this is okay? It's a good practice. Lorena, yes or no? Okay, good. Do this 24, 25. After the rate of change and the rate of change finish, your school will do the polynomial, which we already finished last week. I think next week school you have open house, right? Yes. Always Tuesday, if I remember correct. Why this one takes so long? You get stuck with A and B? You have a function. They told you it's a quadratic. It's a quadratic. You have ax squared plus bx plus c. You don't have ABC value yet. But they told you on the interval. If you say a times -2 squared plus b times -2 plus c equals to 1, wrong. This is not the point. This is the interval. This is an interval. So -2 plug in, you have this. 1 plug in, you have this. You do this two guy difference, y minus y over x minus x. This is f of -2 minus f of 1 over -2 minus 1. That is a slope, which is -3, right here. Another one, interval of 1 to 4. You have, oh, hold on. Yeah, this time I do f of 4. Doesn't matter. I don't want to have too many negatives. That's why I plug in 4. 4 squared is 16. And then 4b, and then plus c, minus 1a, 1b, 1c, divided by 4 minus 1 is 3, equals -5. And then I have the system linear equation. I can solve the a and b value. After you solve the a and b value, you plug in 13 into it, and then you solve. Does your school allow you to use calculator for this part? Yes or no? No. Yeah. Only our 4th students get tortured so much. And you know what? Memorial area, lunch break, you can use a phone. I told those guys there, I said, in 4th ISD, lunch break, no phone. And you cannot put phone in your pocket. Oh my gosh, that's so bad. This is crazy. And they also block the signal. I have trouble to call my kids. They cannot pick they cannot. I call them, they cannot hear me at all. Why this takes so long? Everybody should finish this. Is the number too big? Okay, maybe this number is too big. Okay, I think this part is not hard, just tedious. So you have y equals to a. You solve the a, you solve the b, right? Okay. Now, here is the thing. Yeah, a equals to my a value. My a value is negative 1/3. Okay, Lorena, you have the same a value? Yeah, a is negative 1/3. A is negative 1/3. And they ask you the rate of change for this rate of change. Rate of change. So if you don't want to, if you feel confused how to get this step, look at this. The rate of change is your y equals to negative 1/3 x squared, and the negative 1/3 minus b equals to 3. So b equals to 3 minus 1/3. So this is plus 8/3x plus the c value. The rate of change is using this trick. I still have to teach you guys the derivative stuff, okay? So y prime. Lucas, you learned algebra 2, find a difference with me. Let's do this. We want to do this, guys, first derivative. So we use a power rule. You have negative 1/3. Negative 1/3 put in front. X squared. The constant coefficient in the front, you take it, you carry on. This is square, so you pull the 2 in the front. You pull the 2 in the front. And then you times x to the power 2 minus 1. Okay? And then you have another term here, which is plus 8/3. Copy it down. X to the power 1. So x to the power 1, 1 minus 1 will be 0. So this becomes to negative 2/3 times x to the power 1. And then this guy is x to the power 0 is 1. So this guy will become plus a constant 8/3. If you do the second derivative, this is x to the power 1. So you will copy down the coefficient in the front, and then x to the power 1 derivative is 1, because x to the power 1 minus 1 is 0. So this is negative 2/3. So that is rate of change of the rate of change. Derivative, slope of slope. This is the slope of the slope, which is negative 2/3. If this thing still make you feel confused, I'll give you another example. How many of you are learning AP Physics this year? You can raise your hand. How many people? Really? We don't have any people? Okay, we have, yeah, of course we have physics, yes. If you learn AP Physics, you remember the 1/2 gt squared. This is vertical motion, yeah? Most kids did the ICT class with me. Plus V naught t plus initial height, right? Yes. And then h prime of t, velocity. Velocity is a distance derivative. I should say displacement. Displacement is a vector. Distance is a scalar. So this is a displacement. If you throw something upward, it's going to drop down because of gravity. So that is this. And then, of course, you have a negative in front. H prime t is going to be negative of gt. How do you get negative gt? It's negative 1/2 of g times 2 times t. V0 t derivative is V0. So this is V0 minus gt. This is your velocity formula. And if you do the V prime t, derivative of velocity is called acceleration. Then if you do a constant line, a constant horizontal line derivative is 0. So this is 0. This guy has a coefficient of g. So this guy derivative will be g. You have a negative in front, so you have negative g. Does this make sense? Yes. This is first derivative. This is the derivative, which is the second derivative. So your AT is H double prime over T. Yeah. If you learn physics, you have to do this, right? Yeah. You have to do this. And you will see this in your physics very soon. Now let's keep going. Next one. Let's look at that thing. Let's look at that thing, okay? Let me call student. Leslie, let's do here. Go. Do you think which is inflection point?
B and D.
Good. One more.
D to E.
D to E. Increasing concave down. Okay? Very good. Next one. Owen. 21. This is saying what? Your F is increasing or decreasing?
Increasing.
Negative is decreasing, right? Your F is rate of change is negative, so you are decreasing. But rate of change is increasing, means concave up. Go. Which one you choose?
B to C.
Which one?
B to C. B.
B to C. Let's see. B to C is decreasing and is concave up. Very good. Thank you. Next, Owen, you do one more. 22. At which point you have the tangent line, which is the smallest slope? Which one? Owen. This slope here is like 0, right? This slope here is like 0. This slope here is like this. And this is negative, so you choose B. Got it? Okay, make sense? One more. Which following about the rate of change of F on interval B to D is true? B to D. Which one you choose? Answer me a question here. Is this concave up or concave down?
Concave up, so C.
Yes, very good. rate of change is increasing is concave up. Okay? Got it? Everybody, you feel more comfortable for tomorrow's quiz, right? Yeah? You feel better? Okay. Next. That one is an easy one. You just do the slope. Still, go ahead, quickly do this. This is a simple one. Sometimes they mix the quadratic with the simple linear one to make you feel confused. But this one, see, is a constant, so it's easy. Go quickly. Number 18 is a very easy one. Hold on, Krisha, which question you have? Number 8? You mean number 8? Which one, Krisha? Krisha, unmute yourself. Krisha. Yeah, good job, Sophie. Okay, yeah, this is a simple step question. After you do so many confusing ones, sometimes you mess up even with a simple one. Number 17. Number 17. Sophie, let's see this number 17. I always see, when I see the table question, always check is x increasing by a constant value because I don't want to misleading by this. So first, this is constant. And then I do this difference, right? 31 minus 13 is 18. This is 12. This is 6. This is 0. And then I do this difference, which is a constant. So, Sophie, your first rate of change is not a constant. So this is not a linear one, right?
Yeah.
And then for this guy, you do the difference. Again, it's a constant. So this is what kind of function?
Quadratic.
Quadratic. If it's quadratic, and this is also a constant 6, and it's positive, do you think this guy is opening up or opening down?
Opening up.
Opening up, everybody pay attention, okay? This girl is correct. Then this, you do this direction minus. Don't do that direction, or don't do switch. No, that's crazy. You do this direction. If this is a constant and positive, this is opening up. This guy is concave up or concave down? Sophie?
Wait, can you repeat, please?
It's concave up. Yeah, the parabola opening up is concave up. You hold this cup up, right? Yeah. Okay. So A, B, C, D, you want to choose what?
D.
The average rate of change is a constant. So let's read here, okay? And you're right. Let's see A. Why A is wrong? Because this is not linear, impossible. It's impossible. And then why C is wrong? This is a quadratic. the rate of change is constant. No, the rate of change is not constant. The change of the rate of change is a constant. The change of the rate of change is constant. The derivatives, the slope of the slope is a constant. This guy is saying the first order slope is constant. No, the first order slope is changing. See, this is actually increasing. Do you see? 0 increased to 6, 6 increased to 12, 12 increased to 18. Your rate of change is increasing. That's why you have this concave up. Your rate of change is not constant, so it's not linear. Your rate of change is increasing. So if you do this rate change of rate of change is a positive, so it's a concave up. Or you can say the rate of change is increasing, so it is also concave up. Okay, very good, Sophie. Oh, very good. Next one. Over here. This question comes from this table, okay? This comes from this table. When I see the table, I first check this is a constant interval. And then we will do this. Do the difference. This guy here, the number is big. It's negative 72, negative 44, negative 22, and negative 6. And then you do this, and you found out that it's not a constant value, but doesn't matter. They ask us question here. What is the average rate of change over interval 1 to 4? Go ahead, show me how you get this answer. What is the average rate of change from 1 to 4? Yeah, 1 to 4, okay? 1 to 4. Do this thing first, and then do 15 first, and then do 16. You choose your answer, but you have to write down something why you choose that answer, please. Yeah, when you finish 15, please choose your answer 16 and say some reasons why you make that choice. Yeah, Kelly and Ryan, thank you for getting 15 correct very fast. Student can easily understand this is increasing, this is decreasing. You can also call this increasing. You can even call this increasing. You can call this decreasing. You can also call this decreasing. But when you see this thing, when you see the slope is negative, when the slope is negative, that means it's decreasing. Is this decreasing this way, or is this decreasing this way? I think it's decreasing this way. Why? Because look, your slope is decreasing. You have a mild slope at the beginning. It's negative. -6, and then you go to -22, then -44, then -72. So you must be like this. At the end, you're almost like a vertical. So your rate of change is decreasing. So it's a concave down. This is a concave down, okay? It's this shape. It is not that shape. If your rate of change is increasing, if this is at the beginning, if you have all these numbers switched order, then you will say this one decreasing but concave up, but this one is decreasing concave down. That's 16. Any questions so far? And other students, if you have any question, you feel confused, please ask me, okay? Next one. 14. Look at this. They give you this table, and they ask you on which interval does this decrease the most? Right. They give you this. That is the interval. That's the rate of change. They ask you which interval decrease the most.
Would it
Which one?
would be a C?
You choose C? Look, I know why students choose C. But did they say which one's rate of change is the smallest? This is not ask you the rate change is the smallest. They ask you the decrease the most on the whole interval. So you should use that thing times 0.5. This one is -3 times 1 minus 0, which is -3. This one is -2 times 2. This one is -4 times 0.5. This one is 2 times 1, which is 2. So the guy decrease the most is that guy. No, sorry, this guy, which is 1, 2, 3. You can see how bad this question is. Yeah. If you didn't see this type of question in the test, you probably will miss it because you thought you're looking for that. No. They on purpose make this not the constant value so that student will choose the wrong one. Decrease the most means your delta y. Slope is rate of change. Is delta y over delta x. Decrease the most is asking your delta y. Delta y is the slope times delta x. Your delta x is 0.5, delta x is 2, delta x is 1, delta x is 1. Right, makes sense now? Okay. That's why if you never practice this question in the test, oh my gosh, you messed up, okay? Because you don't know what they want to ask you. That thing is too easy. Plug in, solve it. I want to talk about this, 11. This is the same thing as what I teach you just now. Your f function and g is f of x plus 1 minus fx. And your h is g of x plus 1 minus gx. You can do this x plus 1 minus x. So, Lorena, that's basically who? This is calculated for who?
It calculates 2, 1.
This one is basically calculate the rate of change for f, right?
Oh.
Yeah, and this is calculation. This guy, because divide by 1 means 1 is same as this. So this is calculation for the rate of change for f. And this is to calculation the rate of change for g. So this guy is basically calculate the second derivative for f, right? Yes. So here, they say if second derivative equals 0, then this will be a concave down. Second derivative equals 0. Second derivative equals 0. That means you are a linear function. Your linear function, second derivative will be a constant. So second derivative equals 0. Concavity will be 0. It's not concave down. It's not concave up. That's why when you draw the straight line, I'll ask you to redraw. If you draw a straight line, the second derivative concavity is 0, okay? Yeah, it's not negative or positive. So this thing is wrong. It's false. If you still feel confused, please ask me. Everybody 100% correct? Cleared? You definitely want to read through all of this. I will upload the videos immediately after class. If I finish early, I will update into the chat so that you can watch my video if you have trouble with some question. Number 10. You have, oh, this is another tricky question. Okay, I don't know where they coming up with this crazy question. This is a very crazy question. You have a function g of x, and you have another function which is h of x. G of x has a positive rate of change, which is a linear function going up. And h of x, they have negative slope on the left, positive slope on the right. And then they ask you, g of x plus this, the increasing or decreasing, okay? I don't know where they make this question, but this question is crazy. That guy plus that guy. Previously, if you have a constant line, you shift up, yeah? This thing will not change your increasing, decreasing interval. But this guy, that plus that could be who? If you know, always, sometimes, never, where to put what, raise your hand. Who can solve this question? Think about this carefully. Okay, hold on, give me 1 second. Who figured out this question? Do you think this is a hard one? Hey, everybody, you have to show me your face, your whole face, okay? Yeah, Kelly, Krisha, you have to present your whole face in front of the camera. Otherwise, it's hard for me to know if you understand or not. Kelly, your whole face, everybody show their whole face in front of the camera. Ryan, you have to show your whole face. How do you guys feel about number 10? Katie, your whole face, Katie. Turn your camera. Your eyes, your mouth, your nose, you have to show it. Is this question hard? Yes or no? It's tough, right? Yeah, it's tough. You want to say something always true. So look at this. Over here, this is increasing at least. Over here, this is increasing at least. A increasing plus a increasing will always guarantee you an increasing. Okay? Increasing will always guarantee you increasing. So that thing is always. This is increasing. This is decreasing. This guy's slope, I put it mild, like 0.2, 0.5. This guy has a -1 slope. So this guy going down faster, this guy going up slower. So if this combined with this, you will have a mild going down and you have a sharp going up. But this can go up, so which means this slope and that slope cancel each other. So it can be a flat line and going up. So that means sometimes it's neither increasing or decreasing. So this is also sometimes. And if you have this guy very cute, okay, like this, then the left part is still increasing. And then the right part will increasing faster. So based on this, you can answer your question. If this still you feel confused, I show you guys in my ICT class, I show you guys how to do the slider. How to do the slider. So what I did a g of x. I do a g of x is ax. You don't know the slope, so you put a as a slider. And I put h of x. H of x is b times x absolute value. I don't know the b is how much. That's why I make a b a slider, so I can change my b. After I have both my a and b, and then I write down gx plus hx. Now I'm going to show you this magic using my finger. By the way, students in this class, for those basic easy calculation, we definitely solve by hand. Even the quadratic one, you need to be able to solve by hand. We use calculator to solve this level question. And then you look. Okay? Did you see? Did you see? Why? Because the B and A, when one guy is greater than the other one, you see? You see that? The right part is always increasing. The left part might be increasing, might be decreasing, might be zero, no increasing, no decreasing. In that way, you can answer this question. Okay, hopefully tomorrow's quiz you have same question and all of you should be able to get 100, okay? Any question? 5, 6, 7, 8, 9. If you see this question the first time in the test, how do you feel? Nervous, right? Panic. You guys need to let me know if you have trouble with some topic. Let me know early so that I can grab the best fitted worksheets to help you guys. Okay? Yeah. Thank you, Lorena, for letting me know. Next. Oh, number 4 is an easy one, but look, this one they give you the interval 0 to 30, 30 to 60, 60 to 90, 90 to 120, and they ask you what is true from 0 to 120. Don't overthink. Just this is something build up. Add them 6. Build up. Add them 4. This is greater than that, so you choose B. Okay, that's easy. Don't overthink. Number 2. Number 2 is a tricky one. Okay, f is a quadratic function, and they say which statement is true. They said the rate of change. A quadratic function, the rate of change is a changing one. You don't have a constant rate of change. So this is the crazy wrong. B, the rate of change of the rate of change is 2. I argue about this. They didn't tell us going down or going up. It might be -2 if it's going down. So I don't think this question is accurate enough, okay? This question is not completely accurate. But if you suppose it's opening up, then you can say B. And then C, the rate of change is always positive. The rate of change on the left is negative. On this part, positive. So C is wrong. The rate of change is increasing. That's true. If you suppose this is opening up. But they didn't mention this thing at all. So, or if they give you a graph, that's also okay. So I don't like this question. The rate of change is increasing. If they say this is true, then this is true. The rate of change is increasing means concave up. And last one, the rate of change is linear. The rate of change is linear because x squared derivative equals to 2x. 2x is linear. This is a linear one. X squared derivative is 2x. That's why the rate of change is a linear. That makes sense? Okay. Number 3. Rate of change is decreasing. Rate of change decreasing means concave down. Rate of change is increasing means concave up. From concave down to concave up. Point of inflection. That's C. Now look at this worksheet. If you say, you talk too fast, can you repeat, for example, question 3 or question 11? Go ahead. Ask me for help now. Don't be shy. You have something, feel confused, you ask me, then I make you clear. Then tomorrow you will be confident. Is there any questions? Look, this is a way to prepare for high school AP course, okay? Especially like AP Physics and AP Pre-Calculus, AP Calculus. Let's quick summary. If tomorrow the teacher give you the test, only 6 questions, what should be the question? Okay, let me pick. If I was a teacher, I would pick 6 questions. I will pick this kind of question. I will pick I will pick this question because I read down this and read down this. Student will feel confused. What are you doing? Because x plus 1 minus x, that's a definition of slope. So this is the rate of change. And this is the rate of change of the rate of change. So I will pick this because I know students don't know what is this, what is this. So I will pick this as my first question. And then I will pick this as a second question because I know all the students will not read this carefully and boom, choose that one. Okay. On purpose to fail students like those teachers in Clemens or Dulles Academy for this class, right? Yeah. And then I will pick a table like this. Okay, I will pick a table like this. I know students feel confused about the rate of change increasing or decreasing. This thing here, even I calculate this, I cannot figure out this is what kind of quadratic because this is not constant. I feel nervous. No, that guy is decreasing. This is decreasing and the rate of change is also decreasing. So it has to be this shape. It cannot be this shape. So it has to be a concave down. This is number 3. And then, of course, I will ask this. Okay, I will ask this. And then I don't want everybody to get 90. I want most people below 70. So I give a tedious question like this. Okay, I give a tedious question. And I'm very mean. I want to grab these two into the same. I put the confusing one and the simple one together so that students thought this one is complicated and using the same complicated way to solve this one messed up because I on purpose make this not the same. And then, of course, I will ask a graphing question. This thing will appear in your next year's AP pre-calculus. No, calculus AB, BC, both will have this. Your BC will be really fast paced. So you will have this test in your first week. When other class don't have homework yet, you already have the test for BC. First day you will have a lot of homework. You can also write down here, teacher have an accident with her forehead for her new bookshelf. That's what a cusp is, okay? Or poke into my forehead and a lot of bleeding. That's the 6th question. After today's class, you open the blank one. You redo this 6th question all by yourself. If you can get everything perfectly, you go to sleep. You are safe to go. Otherwise, you want to stay up. You want to do as much as you can. Okay, that's for today's class. If you think today's class really make you less anxiety and feel comfortable, show me a smile in front of the camera. A happy face or angry face, you can choose. Yeah? Yeah? I see your face, I see you can go, okay? Yeah, Leslie, you can go. Don't fake your smile. If you are really happy, you can go, okay? Yeah, Lorena, you can go. Sophie, you can go. Lucas, you can go. Ryan, you can go. Brianna, you can go. Oh, I had to see your face. Yeah, Kelly, you can go. Yeah, Krisha, happy? You happy?
Yeah.
Okay.
I sent you a problem that's on our quiz tomorrow because it's like I think Clemens is covering like rate of change, but we haven't covered that yet. We're covering like even, odd, and like symmetry and stuff.